Hello, geometry students, and welcome back to another video lesson where today we look at two more congruence theorems and some unique situations that allow us to use these two congruence theorems. Now, again, we're still working on the proofs part. You do have a test at the end of the week, test on Friday, so we're preparing to kind of get all of this ready. Based on the information given in each of the triangles, do we have sufficient information to determine congruency based on the side lengths? And what's different about the two triangles? So hopefully you recognize that in both of them, we've got a side, followed by a side, followed by an angle. We've got a side, followed by a side, followed by an angle. And as we described, SsA is not allowed. At this point, we're going to describe a stipulation that does allow it in a moment, but we currently can't use this in any of them. Now, if you notice in this one, I've got an angle that's given, and if I look across from the angle, this side is 2.34, and then the side next to it is 3.85. Whereas in this triangle, 44, and the side opposite is 4, but the side next to it is 2.17. So there's a unique relationship, particularly in this one, that does allow us to use a property called big S, little s, A. I'm going to explain that on this slide. Big S, little s, A, side angle, only works if the side across from the angle that you know is bigger than the side of the other given information. So as you can see in this one, we were given this angle 29, and the side opposite was 2.34. But 2.34 is less than the other side, 3.85, right? That side is smaller, so it doesn't work in this case. However, we're given 44 and the side opposite is 4, and 4 is definitely greater than the other side we're given, which is 2.17. So big S, little s, A does work in this one, and we can now use that as a triangle congruence theorem, provided that it meets that criteria. The side opposite the angle has to be greater than the other side we're given. It doesn't have to be the biggest side of the triangle. It just has to be bigger than the other one that we're given. Let's take a look at these three and try to determine, I'm going to cover up the other two for a moment, determine if we can use that big S, little s, A in these. How about number one? Can we use big S, little s, A? Unfortunately, in this one, we cannot. Here's my angle, so I'm going to draw an arrow to the opposite side, 2.04, and then the other side we're given is 3.73. And because it's less than, we cannot use that in the example. How about number two? Well, in number two, if we look at our angle, we've got 39. The side opposite is 3.52, and 3.52 is greater than 2.89. So therefore, we could say that big S, little s, A would indeed work for this one, because the side opposite the angle is larger than the other side we are given. The last one, this is 65, this is 3.21, and this is 3.2. Are we able to use it? So the opposite side is 3.21 bigger or greater than 3.2. And in order to tell that, you might have to add a 0 here. It certainly is, right? I'd rather have $3.21 than $3.20. And because the side opposite the given angle is bigger than the other side, it indeed would work here as well. So that's how big S, little SsA works. As long as the side opposite the angle we're given is bigger than the other side, we may use it. What about this one, though? Here's a right triangle, and they labeled two sides. One of the things we have to try and remember in a right triangle is to label our information. So the side opposite the right angle is called the hypotenuse. And what do you remember about a hypotenuse? The hypotenuse will always be the longest side of a triangle. That's a property that we were given really early in this geometry school year. So anytime we have a right angle and we have that hypotenuse, we can use a special version of big S, little sa, which is called HL, which stands for hypotenuse leg. As long as we know that the hypotenuse is there, we can use HL. Okay, it's a special condition of big S, little sa because of the 90-degree situation. And we call it HL, standing for the hypotenuse and leg. So we have to be given that the hypotenuses are congruent and that one of the other legs are congruent. So let's take a look and see, what does that look like, though, in a proof? Like, what's the big deal? So we're given that DE is a perpendicular bisector of FE or FC, perpendicular bisector, and that DF is congruent to DC, and we're trying to prove two triangles congruent. So I've copied down the given, and I've written the word given over here, and now we got to go to step 2. The clue is that they tell you something up here, that DE is a perpendicular bisector of FC. So that means we need to define what that gives us. Well, one of the things that it gives us is that these are right angles. Angle DEF and angle DEC are right angles. That is definition of perpendicular. Anytime two lines are perpendicular, they have to intersect at a 90-degree angle. So definition of, I'm going to use this symbol, definition of perpendicular. We also know then, because it's a perpendicular bisector, the bisector part tells me that this is congruent to this. So that segment FE is congruent to segment EC, which means number 3 is the definition of perpendicular bisector. Right? So we want to use the information that they're giving to us as part of the given within our justifications. Remember now, they also told us in the given that DF was congruent to DC. And now, in these two triangles, I have a hypotenuse congruent to a hypotenuse over there, because they're right angles, and a leg, which means number 4 allows us to go right to saying that the two triangles are congruent. Triangle DEF is congruent to triangle DEC. What allows us to say that? HL, the hypotenuse leg congruence. And again, because the two hypotenuses are congruent to each other, we knew that this leg and this leg were congruent because of perpendicular bisector definition. We also knew that they were right triangles because it was perpendicular, allows us to jump to that. Now, some of you may be wondering, well, isn't DE the same in both? And it is, right? This side is also the same in both. But that would have made us take another step, number 4, to say that DE is congruent to DE reflexive. And then we could have used side, side, side. We could have used side, angle, side, a number of different options there. So by using HL, we are, in a sense, are able to cut out an extra step. You get some practice problems on this today. Really, really work on practicing your proofs as we get prepared for your test scheduled for Friday. If you do have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.